Slowly starting. So welcome everyone to the meeting of the DMP Common Standards Working Group. They want to talk mostly about the maintenance of the standards and adoptions. The agenda of the meeting is as follows. There are 4 parts of the meeting. In the first one, which we have foreseen for about roughly 10 minutes, we want to give introduction for newcomers and to give some status updates. So if you are new to this working group, first time in the meeting, you have a chance to catch up quickly what we have been doing in the last few years. In the second part, we're going to have quick news about recent developments in the area of DMPs, and we'll have 4 invited speakers who will present different aspects of implementing, of adopting the recommendation that this group has produced. And the second part is foreseen for roughly 30 minutes. So each presentation is about 5 to 7 minutes, and then there is time for some questions, like 1 or 2 questions. In the part 3 of this meeting, we want to have more discussion with you. We want to do the maintenance of the standard, meaning there is a set of issues we have identified, a set of suggestions, and we would like to present them to you and basically get your feedback on whether you think we should make some improvements, some changes or not. And in part 4, we want to wrap up this session. This is a moment where we can also bring any other topics, and maybe there are some things we should tackle together to ease adoption of DMPs. So this is the agenda of the session. If you want to ask any questions, please do them in the chat, or if we have presentations of the speakers, or when we ask for feedback, just please unmute and speak. Before we start, we would like to get to know you a bit more, and we have prepared 3 quick questions to you in Slido. So please get your mobile phones ready, and please sign the code, and we will display a quick poll. In the meantime, I would like to also point you to the collaborative notes that are published in the description of our session. Please add your name to the list so that we have a track of who was here with us today. And please also co-edit, so you can write key points that you find relevant that you have heard in this session, or maybe provide links to any suggestions you may have. We'll later review the meeting minutes. So if you're ready with Slido, if you have your phone in your hand, let's start with the first question. So the first question is, how familiar are you with DMPs? And we would like to find out whether you are here for the first time, or you have been already with us for quite some long. And those who are first time, are you considering adoption, or you just came here by accident and you want to find out what this group is about? So I see that most of you right now, 63% is interested in the topic, but for the first time here. Cool, that's quite some people. Unfortunately, as a presenter, I don't know how many people we have in the meeting room. So as long as the numbers will be going up, I assume you are still voting, and then I will switch to the second question, but so far you are still voting. So 56% out of 32 votes are here for the first time. And we have only 6% or 5% of people who adopted. Can we make it 40? We have 38 votes, up to 40. Still someone? Okay. Let's continue to the next question, which is, what is your background? So please tell us whether you are a person working with the IT infrastructure implementing DMPs, or are you a research support, or are you a policymaker? You come from funder angle or from a research institution? Are you a scientist, researcher? We left it open to you to best find the keywords that describes who you are, and sometimes more than one keyword is possible. So please type in any keywords that are most suiting who you are. So I see the biggest one is research support. We have librarians, some infrastructure providers, data repository curators, DMP tool providers, publishers. Research support, I see, is the main in our list. We have 45 votes. You're much quicker now with the second question. Okay, can we make it 50, 46, anyone else? We have also some software developers, 48. Okay, let's get to the next question, the last one in this series. Where are you located? So we leave it open. You can say which country, which continent, which building if you want. But I guess telling us about your country and maybe city, I guess country will be the most relevant for us. So I see Europe is very well represented, UK, Germany, Finland, Netherlands, Norway. We have Greece, Scotland, Denmark, Singapore, Indonesia, Lithuania, US, Helsinki, Brussels. Oh, we've got also some folks from US. Good to see you. 51 votes. Okay, so we know already something about you. So we come from basically around the world. We have some people who are here for the first time. So let's start with the introduction for the newcomers. So the story of this working group begins with the data management plans and with the requirements created by funders that researchers are supposed to write a data management plan. And usually DMPs, and they are still a document that researchers have to fill out, providing a lot of explanations on different aspects of data management. There are some checklists or some guidance, like you can see here in the slide from the Science Europe, but also we have guidance from other funders around the world. And what we understood as a working group in 2016 or 17, if I remember well, that we cannot put the responsibility only on the researcher to fill in the DMP, and we can improve the whole experience of creating a DMP if we manage to pull together different stakeholders. So when the process of writing a DMP, things like estimating costs, finding storage, identifying appropriate licenses, can be a shared responsibility between the infrastructure operators, research support, researchers, and also the management. And to make this possible, we identified three things as necessary. We needed a well-defined RDM workflow, so we needed to know who is responsible for what. We needed a data management infrastructure, so basically all these IT systems that support the exchange of information between the stakeholders. And we also need a common way to represent information, a common standard to describe contents of a data management plan independent of a specific funder requirements. And this working group produced a recommendation on machine actionable data management plans. This recommendation is a two-pager in which we outline the purpose and give an overview of classes. This is an application profile which defines a set of concepts that you can use to express a minimum common set of information that you will find in a data management plan. So this is an example of how our recommendation looks like. This is a set of fields. Each of them has a description and information on cardinality, whether it's obligatory or optional. So we didn't come up with a question or a template that is supposed to replace requirements of the funders. We wanted to create something that can be an information carrier, something that will facilitate exchange of information between the systems. And the key focus is machine actionability. We didn't want to model questions and answer to questions, but we focused on modeling information. So in this case, you can see that we are modeling a person, we are collecting information on a contact person for a DMP, and we are not coming up with a question like who is the principal investigator or who will be the contact person. We have one field for which you have to provide exactly the email address or the ORCID ID. This is up to the specification. Similar about costs, little narrative, a lot of precise information about precise data. So to sum up how the vision of machine actionable DMPs fits into the whole infrastructure, into the whole setting of research data management, you can see it in this figure. We see machine actionable DMPs as a way to exchange information between systems. So for example, you can get information on researchers from the existing CRIS systems operated by universities. You can get information on data deposited to repositories from them using the integrations over the APIs. You can also get information on the quality of service and other information from registries like referee data and so on. And eventually, you can submit the machine actionable data management plan to funders to also facilitate the validation and getting the information on what's happening actually with the research data by funders. So the benefit is primarily to the researchers, but actually everyone who is a stakeholder in research data management can benefit by having an easy way to exchange information. And currently, we have a set of adoptions. These are the logos of organizations that have already started adopting the recommendation, already have adopted. So we have most of the key data management planning tools like DMP Online, Data Stewardship Wizard, the Research Data Management Organizer, Argos. We have some repositories like Haplo repository, funders like F1000, or infrastructures established for research data management in countries like Austria or in Norway. There are some more adoptions also pending that sometimes we even don't know as chairs of the session. When it comes to the activities and becoming engaged with this working group, we are making announcements via a mailing list, so please remember to sign up. And the discussion on the standard itself and the maintenance of the standard is in the GitHub issues where the recommendation is also published. From time to time, we organize events. So, for example, last year we had a hackathon on machine actionable data management plans. We have many participants from many countries, and we have built teams to work on specific challenges like how to actually apply the recommendation, how to integrate the systems, how to map them to funder templates, and things like this. You can also see the results of the hackathon online. All the links are provided in this presentation that will be shared afterwards. This is everything what we had foreseen as an introduction for the newcomers. So if you have any questions, please ask them now if something is not clear, before we move to part 2. Okay, I don't hear any questions. So now we are moving to part 2, in which we will have the community updates and adoptions. So I will start with 4 news items, and then I will hand over to our speakers. So the first news is that we have some examples of MA DMPs and DMPs. So you have there is a Zenodo community, and the same information is expressed as a DMP according to the Science Europe template, and also as machine actionable DMP. If you follow the link, you can always find relevant DMPs. There's always this prefix DMP or machine actionable DMP if you want to compare them. Another news item is that there is an XML representation of the standard being developed by our colleagues in France. They have already some preliminary results, the XSD schema, and a representation of the recommendation made in visual paradigm. They will release it when it's finished. So far, it's work in progress, but I think it's important for everyone to know about this work who is considering to adopt the recommendation and is going to use XML for exchange of information. Since the last plenary meeting we had in November, we had the chance to present to Science Europe, to present our work, what the group has been doing, and the feedback was very positive. One main question from the Science Europe, who is the board of funders in Europe, was are there any specific tools or software that they could use or recommend to the researchers which benefit from the automation that we have described to them? And I know that there's some adoptions going on, but if you are one of the tool providers, I think you should talk to your funder because they may be interested in the work on MA DMPs. And in the meantime, we also had some meetings with people who are implementing data repositories. In this case, it was a webinar for people who are interested in the Dataverse project. And in this case, we are discussing how the MADMPs can integrate with Dataverse. There is a webinar recording you can also watch later on YouTube. Last but not least, there are 2 papers on the MADMPs which are still in the review. We have submitted them to the special issue of Data Science Journal. The special issue is on outputs produced by RDA working groups. We have one paper describing all the adoption stories and methodology of developing the standard, and the second one, which is a summary of results from the hackathon. Unfortunately, the papers are already 280 days in the review, and we still haven't received any feedback. So if anyone from you is wondering what has happened with all the papers you were participating in writing, they are not lost, they are not forgotten. We still wait for the final decision from the journal. And this is it when it comes to the news from my side. Now I would like to invite our speakers for their short presentations and updates on what they have been doing recently regarding the MADMPs. So the first one will be Zeno, then Björn, Eli, and Fajar. Zeno is here with me, so he will come and talk for the next 5 to 7 minutes. Welcome, Zeno.
Hello, everyone. That was a smooth transition. I am one of the developers for the DMP tool. That's a data management plan lifecycle support tool we're developing at the Technical University of Vienna under the Fair Data Austria program. So just to catch you up, what the Fair Data Austria is, basically it aims to enable more efficient research data management by supporting the lifecycle of the research data from start to finish, and also wants to enable smoother transfer between the different research institutions collaborating on a project or just on the data. In order to do this, they have some initiatives going. So it's research data management training, different support services, teaching how to do proper research data management, but also offering informations, all that kind of stuff. They are supporting the development of a new repository for research data. And they're also supporting us in developing a tool for managing DMP life cycles. And I'm going to go into more detail on that. So this is our team. We are 5 people at the Technical University of Vienna, 3 in the development branch, 2 for our specific center for research data management. And we also have 2 developer colleagues from the Technical University of Graz that are aiding us in the development. And what's the tool about? So we want to assist a user, a researcher, to create a data management plan, and we want this to be as easy for them as possible. So we follow all the core design principles of MADMPs, like Tomas previously iterated on. We want to automate as many processes as possible. All the information collection should be automated, triggering actions between different tools. And in order to do this, we have designed a tool that's very closely integrated into our tool environment at the university. And by doing all this, the tool can generate a pre-compiled data management plan as a Word file, for example, and the researcher can then just go in, edit if something isn't right. So it's comply or explain. They look through it. Anything that needs more explanation, they just add. This is how it works. The user logs in through our university login system that authenticates them with the tool. The user goes to create a DMP. They then get from our university project database a list of their projects. They select their project. They get a list of their co-workers on the project still from our database. and they add them onto the DMP as well. They can then define research data they are working on. They can then add storage where this data is located, and then add a repository where this data is published. We source this from our retrieve data, which basically edits and keeps this list of repositories up to date. The tool then generates two different outputs, a precompiled Word document that's just based on the Science Europe template. It fills out what's missing. And the advantage of a Word template is the researcher can edit any text that might not be human readable or add any additional information the form didn't take account of. And we generate an EMMA DMP output in form of a JSON that's ready to be sent to any tool that might support it. And then finally, the document can be submitted to the funders. So just to make clear, this is not an idea proof of concept. This is what we already have right now. It's not on production. We still have to go to several additional minute topics to fix. You know, at admin support, we need a team to assist the researcher if they need help with the content, stuff like that, basic institutional support. But we have already implemented the steps you see right now. And for the future, we intend to expand this further. So we want to integrate ORCID as an additional login authentication option, so you can invite your colleagues from other universities or institutions to collaborate and edit the DMP. The Technical University of Vienna is adding Invenio RDM as a dataset repository. We want to connect with that, so instead of inputting what your dataset is, you just select it from a list of your own datasets. And we also want to be more closely tied to our storage solutions. So our university offers GitLab, OwnCloud, files, and so on and so forth, different repository and storage solutions. And by connecting with them, we again enable the user just to select their options, and all the metadata will be included as by default. And the idea is, if you at your institution want to integrate this project, you basically replace the connections that are different for you. So you won't be authenticated through the Technical University of Vienna, your projects and people information won't be there. So you replace it with your institution system. You replace your own dataset repository, your own storage solutions. And once you fix that, you're good to go. Maybe you map to a template that's relevant to your funders in your country. The FFG and FF here are Austrian examples, our main funders, but you know, we will expand that list, of course. And that's pretty much it. I don't know if I have much time. So this is what it looked like, but I don't have time to go through it. Please feel free to ask some questions if you have any. Okay, I'm not seeing anything, so I will pass back on to Thomas.
Maybe, sorry, this is Christina. I just wanted to check if you could go back one slide because you showed it how it looks like.
Yeah, you can check the slides after the meeting. It's basically our form, and it offers, in this case, it's the list of projects. These are sourced from our project database for our scientist Andreas Lauber, who we're using as our test researcher. And he basically selects the project by its title, and the tool in the background knows the project data and can pull it from our project database. So the user doesn't add any additional project information because we already have that. They just select for which project this DMP is. And in the next screen, he gets a list of people working on this project. In this example, he set himself as the contact for the DMP. and a colleague as a data curator, and we have different roles supported. Going again, these are our internal storage solutions. These are hard-coded right now, but we're planning some more interactivity with it. And this is the repository list from R3 data, which we load live from them and can be searched from. Any more questions?
Yes, there's a couple of questions in the Q&A tab.
Again, I didn't get that. Sorry.
There's a couple of questions in the Q&A tab on the right-hand side.
Oh, I'm sorry.
So there's one question: how does it compare with the data stewardship wizard? Basically, the main difference, maybe I will answer it. The main difference with data stewardship wizard is that this tool is meant to be run on premises at the specific institution, so it tightly integrates with the data sources you have available. And data stewardship wizard, I think, was more meant to be run independently, so open to all researchers and not supporting researchers of a specific institution in mind.
Identifiers for people, yes, the EMMA DMP standard intends to use ORCID and other persistent identifiers. It also depends on what you have at your university. We store ORCID IDs for our researchers optionally, so the tool will include them if available. If the funder requires the ORCID ID and the tool didn't source it from the database because the researcher didn't give us this information, they can add it in the document before submitting. That's the prerogative. Different DMPs based on different. So you have to adapt the tool to your environment, to your tools, to the applications you have available.
So maybe the last question: will it be possible to test it once in production?
Yeah, I mean, we can show it off. At the moment, we can't give access for free to everyone. That's something we would have to implement.
Okay, thank you very much, Zeno. We have to switch to the next presentation. The next presentation is by Björn. I will stop sharing my screen, and Björn, please share your screen. We can see you now, and we are waiting for your screen.
Do you see my slides?
Yes, we do. The floor is yours.
Thank you very much. So my name is Björn Brötz, and I will give a very brief spotlight on developments that we are currently doing. Me and my colleague Daniel Mohr, who is also present, we are from the German Aerospace Center, and they are from the Institute of Atmospheric Physics, and I'm the data manager over there, research data management. So we would like maybe to use the machine actionable data management plans in a way that it's maybe not originally intended for. We would like to use it for automated checks and metadata annotation for the early life cycle of our data. And I would be very interested in your comments on this approach. So just a brief background. We are the Institute of Atmospheric Physics at the DLR in Germany. Colleagues are doing basic research in atmospheric science. And the research data that is coming up there is from both observation and simulations. And we have a number of laboratories, but the colleagues are also performing measurements that are airborne on planes like this one here, and a number of variety of observations in situ and remote. I will only talk about the observation part, but of course we have colleagues also that are doing simulations of climate and weather and process understanding. I would like to sketch in a very abstract way the process of research data lifecycle as we see it. So it starts in the upper left corner with the observation, and we colleagues receive the raw data of the instrument. Then a physical data is product is derived from this, and to achieve these, you have a number of elements who enter these process. So you need to scientists need to make assumptions on what was measured. For instance, in our context, it's often relevant to make an assumption about the shape of the particles that are measured in the atmosphere. For instance, are they spherical or not? So these are scientific assumptions that go in there. Also, supporting data from other instruments are needed. For instance, you might need temperature recordings in order to interpret your original measurements. So also additional data is needed to derive the physical data from it. Then, of course, calibration information. Usually your instrument is calibrated in a laboratory, and then what was recorded there is needed for this process. And also it's important to know the context when where the observation was made. One classic example is colleagues of mine are performing measurements in the contrail of there's a very spectacular measurements, a contrail of commercial airliners. So you have like a chase situation where 100 meters behind a commercial aircraft, the research aircraft is probing the atmosphere. And if you don't know that context later on in when you find these data, you would be very confused by the measurements, of course, that they are very specific on the context. But this is true for all situations. Then physical data is derived. Then the science starts. Scientific data is generated as an iterative process, and scientific insight is gained and also recorded. And this leads then to a publication. And finally, this all goes down in an archive where all those single elements of these abstract layout has to be considered. Now comes the problem. There is something that I would like to describe as the effort for the scientist required to document all metadata properly. It usually goes like this: you make the observation, then you do your science, and you record all important information, of course, but you don't record them in a way that is like needed in a certain format, in a certain degree of information that is needed for reuse of the data set. So when the moment comes when you publish your findings and your data, then shortly before there comes this hectic situation where you have to reassess all documentation that was done before in order to assemble all these metadata in order to have your data published, have your paper published, and that creates a lot of stress and problem. So that's basically what we are facing. We try to find a way out of this situation. Basically, a way to flatten this curve that I showed you before, with a system that is based, that is analogous to the continuous integration of software engineering. In software engineering, you have this process where you develop code, and some machine checks certain attributes of your code quality, internal tests, and this is done automatically, and the result is presented to you in a very clear way. So we thought maybe we can take this idea from software engineering and put it into research data management. And so this is a workflow depicted for the system that is currently under development. So you imagine you're one of these scientists. You would like to upload your data to some internal storage, and we thought we would need some kind of set of rules that are the basis of this check that we would like to perform. And we thought for the machine actionable data management plan as being appropriate for that. So there shall be also a repository for the machine actionable data management plan called DMP here, which is also uploaded to our system. And then a controller, which is something automatic, an automatic machine reads this machine actionable data management plan and starts scanning and testing the data that is placed in the system for compliance with respect to this machine actionable data management plan. And the result of this is then communicated to some kind of internal metadata base where the user receives the feedback. So when he or she goes to this internal website, to this internal metadata website, the feedback will be something like, oh, 80% of your data is good, but 20% has something that you still have to work on. And then in an iterative process, the scientist receives can make his data good in a way that everything is green. So make everything compliant with the data management plan. And because this is a continuous process that is available to the scientists from the very beginning, you will have it very transparent, the state in which your data is with respect to what it should be according to the data management plan. And okay, so I think I skipped the rest. Yeah, this is just the same with the publication part in it. But basically, I said everything what I wanted to say. We are intending to use the machine actionable data management plan as a set of rules in order to check our data. That's it. Thank you.
Thank you very much, Björn. We can take one or two questions. Björn, if you want, you can just jump to the Q&A, but I see there's one question for you. Is it open source?
Yes, well, it's still in an early development phase, but it will be open source. Yes, this is our intention.
And there's one more. How do you validate domain-specific aspects?
The idea is that, and I'm not sure if this fits still in the current state of the data management, the machine actionable data management plan. So we envision a hierarchy of data management plans. So there should be the one that is like maybe on an institute level, where maybe the superior boss says everything should be under a certain license, for instance, and then maybe on a more scientific level, where the scientific groups are acting, different sets of rules are made. So we intend to have like a hierarchy of data management plans that that can be then refined on the domain that they are relevant for, down to the instrument that was measured for. Yeah.
Thank you. Paulette, do you want to ask a question?
Yes, there is another question. Hello, everyone. There is another question in the question and answer. It's very difficult to read, I find. Yeah, how do you fill in the metadata? Is it filled in automatically, or what are your mechanisms to do this in the early data life cycle?
Yeah, well, most of when I showed this abstract view is this is a very abstract view. Of course, your individual instrument is very specific, and something that is important for one instrument is not important for the other one, and so on. So it has to be in the end the individual scientist and the scientific groups that he's working in that are defining what is required and what is not required, and then it has to be the scientist who feeds in the information, like scientific assumptions and so on. Yeah.
The scope of your tool is not to provide help or in guidance in filling in the metadata. It's just the next step, which is documenting or actually checking if such and such metadata is actually present or not. Excellent.
Yeah,
Thank you very much.
yes, thank you.
Thank you very much for the questions. Thank you very much to the speaker. The time is pressing, so now let's go to our third speaker today, Ellie, who is going to talk about the Argos DMP outputs and integrations. Ellie, please share your screen. The floor is yours.
Yes. Thank you. I hope you can hear me. All right, let me share this. Is it good? Does everyone see my screen, the presentation?
Yes, we do. Everything is perfect.
Perfect. Thank you. All right. So, hi everyone. I am Ellie Papadopoulou. I work for Athena Research and Innovation Center in Greece, and I'm also involved in a project, OpenAir, which has been the project. Now it's a legal entity. It's essentially the electronic infrastructure for open scholarly communication in Europe. So it supports scholarly communication. And one of the tools that we have developed is Argos, which has to do with data management planning. So this is what I'm going to present here and how we have integrated the standard, proposed by the RDA. So an overview about what Argos is. Argos is an open source, configurable and extensible tool for data management planning. So it helps everyone create their data management plans according to open and fair data policies, followed by different stakeholders. It's open source, as I mentioned, so everyone can go and check it out and push new, let's say, features if they want us to add. So it can be collaborative and participatory in that sense, the development of Argos. Different disciplines, different scientific domains can work and configure their own standards and their own protocols. So we have at the end, let's say, more tailored DMPs and to the scientific domain they represent. And of course, it's extensible. Again, as I mentioned, it's open source, so everyone can use it and extend it further. You can find it under argos.openair.eu. Our main users are researchers, research projects, funders, research communities, and institutions. And it can be used as an online tool, but also we can have ad hoc installations if people are interested. If, for example, funders or institutions are interested, we have those kind of users in our user base, and we're working with them as we speak. So it's free to use for researchers. Other than that, and it's also an EOSC research, a European Open Science Cloud research. So it's available through EOSC also. Some key features about Argos. It supports the DMP generation, but also the publication process. So it aims to, and it does actually, close the DMP life cycle by also not only generating DMPs, but publishing them in following the open and fair principles. So it treats the output, it treats DMPs as outputs, as open and fair outputs as much as possible. Those outputs are machine actionable because we have integrated the RDA standard, as I mentioned before, and through that we also try to normalize the descriptions of data, meaning that we try to support interdisciplinarity and multidisciplinarity of DMPs. So provide more control over the data sets rather than the whole DMP or the data sets or a pool of data sets described in a single DMP. So we try to normalize, as I mentioned, the descriptions of data by having in mind and taking into consideration the different criteria that are attached to different data sets according to their status, according to their discipline. So, for example, different things have to be considered for data that are now being produced. Different things have to be considered for data on the DMP for the data that are reused. There are different processes, for example, where can someone find the data, how the copyright clearance has a copyright clearance process being followed, and so on. So different criteria, sensitive data, some of them maybe we cannot we cannot, we have the access conditions, okay, we apply to sensitive data, but we can, in Argos, you can tick and unselect this particular data set from being published from in the single DMP, in the whole DMP, and of course, discipline specific data sets can be described with the data domain protocols and standards. It's interlinked, it's connected to different reference services and data sources, which is made possible by utilizing this graph, which is a knowledge graph. I will talk about that in a minute. But for the Argos lifecycle, this is what it looks like. We start by drafting the DMP. We have two different editors in order to do that. We have the DMP editor, which collects everything, all metadata that have to do with DMP, so at the level of the DMP, but also at the level of the data set. So all metadata are here. And then for the dataset editor, we also provide more, let's say, granularity to different fields that have to be completed. So for example, there are some data, for example, metadata, PIDs, and so on. Throughout this, then we validate. Someone can validate the Argos outputs and then finalize them, of course, either in Argos or publish them there's a button that you can click. It's called deposit. So it immediately generates a record in Zenodo on Zenodo, and this version has a DOI and has a license, so people know how to reuse it. To reuse this DMP. Throughout this whole process, we try to make use out of the more than 14,000, yes, correct, reference resources that we aggregate from different providers that we find under OpenAir APIs. And also we make this possible, we integrate the RDMP common standard, so we are compatible and the DMPs are interoperable at the end. So I think I've explained this. At the end, we have a DMP output, which has been produced according to OpenAir principles. It is not only a plain text, but it's a rich document. It includes the granularity of the data sets. It's discoverable. It keeps the history of the versions and the provenance of the metadata. It's accessible by reusable and preserved in Zenodo. So how this looks like in our environment, in the OpenAir environment, is we have Argos, we have integrated Zenodo, so we produce the machine actionable output. Once this is done, we can then, because we have some standardized, let's say, data model, but the data model is now also following the standard, so we can then take one of the entities of the standard and link to different services that we have. So for example, when someone, we link with the repository network, so when someone submits a DMP from Argos and lists one repository that he or she is going to use, then we send notifications to this repository manager after having talked with them and integrated this repository with Argos. We send notifications so that they can organize themselves, especially when we were talking about data-intensive activities and big, very big data sets. Once the DMP enters the OpenAir research graph, which is a huge knowledge graph, contains the wealth of information of the wealth of open access information from European projects and different global providers also. This Argos output becomes an entity, so we can link to different entities within this linked ecosystem, and we link currently the Argos outputs with the datasets that they describe and with the project that they are submitting this DMP for. And then we provide information to the monitoring and usage counts. These are services that have to do with trying to understand the impact and the evolution of specific outputs and open science in general, and research data management. So by doing that, we can see with tailored indicators that we develop, we can see, for example, what are the different standards that are used in specific domains, and if there is a need for some new standards to be developed, then we can have like those kind of let's say observations on the evolution of the RDM. And then everything, as I mentioned, is findable in OpenAir Explorer, and they're fundable under the correct resource type because we're using the nodal, so it's exposed under resource type data management. What I wanted to focus my presentation on is actually this, because we are, of course, our ongoing work is to work with, to grow our templates collection and enable their actionability, and we're doing that already. We're working closely with research funders and institutions across Europe. To enhance the multidisciplinarity of DMPs by implementing more domain data protocols. Currently, we have 2 or 3. Continue work on new features, of course, and then a question that I would like to do, because I know that we are a fairly new tool, and we haven't been that much engaged since the beginning in this interest group. But it would be good to know what other people think, and it would be good if we could develop a DMP tools or services registry from within this community, so that we keep, let's say, we make easier for the researchers to search for their DMP tool, but also easier the exchange of different information, the different features that are important for the communities. We can understand better if we have a registry and so on. So that's from me, an open question. Basically, this is what I want to end with. Thank you.
Thank you very much, Eli. Thank you very much for this question. Actually, our schedule is very pressing, so we can take maybe one question from the top, and then I hope you can answer other questions in the chat directly. So the first one I see is, does Argos produce also traditional format versions of DMPs that can be submitted to funders?
Yes, we produce PDF, text, XML, and JSON.
And who validates the DMPs? The researcher, the RPO, the funder, or all of the above?
The one that the validation from the process that I showed is a first set of validation done by us. It's just the basic validation that you do for mandatory fields. That's to check if all the mandatory fields have been completed. But other than that, yes, for the information provided, it's up to the researchers. Okay.
Thank you very much. I have to now pass on to the next presenter, last but not least, is Fajar Kaputra, who is going to talk about ontology representation of the recommendation. Fajar, the floor is yours, and please stay within the time limits. Thanks.
I'll try. So let's. Do you see my screen now? Can you see my screen?
Yes, we do.
Okay. So hi everyone. My name is Putra. I'm from TU Wien, and here this is presenting the work that we did. Joao, Leila, Marie, and others, mainly in the hackathon last year on the ontological representation of DMA and DMP. Well, I don't have to tell you about the DMP common standard, but 2 important things that I want to point out is that it provides this technology agnostic application profile, and it reuses some concept from the existing ontologies, for example, from DCAT, data catalog, or FOAF to describe person. So it's already there, but why such ontology is still needed? We have 3 goals in mind where we are designing this ontology. The first one is to allow explicit linking of DCF concept to other existing ontologies. The second one is to facilitate the definition of a set of control vocabularies for part of DMP concept. So to make sure that you can actually have like a set of values that you can choose from And the third one is to facilitate extension mechanism. This is an alternative to the DMP common standard. I will go into more details in the next slides. So just to introduce you, the Dcso ontology consists of two parts. The first one is the core. This is the link. You can take a look in there.
Sorry to interrupt, Fajar. Can you maybe try to restart your screen sharing, because I think the slides are jammed and are not displayed properly. So if you could just try to share the slides, share the window again.
So when there are issues like this, sometimes some people will see the slide advance and some won't. But yeah, it does no harm to start again, and then that should resync it for everyone.
Is this now okay?
Now it's worked. Okay, yeah.
Okay, please let me know again.
Number 4, yeah.
Okay. Probably I can also turn off the video. Helps probably. Let's see. Okay. So in here, I'm talking about the Dcso Core. So this is basically really a mirror of the DCS concepts. So you have all the concept attributes and relation plus. This is something that we add is the concept identification class, where you have what type of it and the value. So you can say that something like person has identifier with ORCID type and this value. I don't know who it is, basically, actually. And the second one is that we provide the explicit mapping to the existing ontologies, such as FOAF and DCAT. This is how it looks like. So you have, for all the main concept in the DCS, you have the corresponding classes in the DCSO. And in here, additionally, you have some explicit mapping for those that actually can be linked with the existing ontology, such as this DCSO dataset. This is, we can say that this is a subclass of the DCAT dataset. Means that if other people are using DCAT to describe their dataset, you can actually integrate this data together. DCSO datasets can be seen as instance also of the DCAT dataset because it's a subclass of. In here, this is answering our first goal to do this explicit linking of the concept to other existing ontologies. Okay, the second part is about the controlled vocabulary. So when we are creating this ontology, we realize that for some concepts, actually you can make this controlled vocabulary definition, but this shouldn't be part of the core. This should be somewhere else. So we came up with this extension with using another namespace where we store information about all the controlled vocabulary definition. For example, currently we have countries, currencies, and languages. And in here we just demo. Yes?
Father, sorry to interrupt you. There is again the problem with your slides. Tell me which slide you are on. Maybe I will try to share the slides from my screen.
Okay, now I'm slide 6.
Okay, wait. I'm turning on screen sharing. Can you see the presentation from my desktop?
Yes. Okay, sounds good. Okay, let's do that. Okay, so in here, we actually provide this. So to make sure that for some of this value or terms, you can pre-select the information from what is available. For example, for countries, we use this ISO standard, the list of ISO standard, to allow user to choose something from. Can you go to the next slide, please? This is how it looks like. So you see that, for example, when you're describing the cost of a data management plan, you wanted to know, for example, you say that this is cost 10,000, but what kind of 10,000? Euros, USD, or Indonesian rupiahs, for example. So here you can describe this. So additionally, to make sure that you have a precise information given to the funder and other people, stakeholder that's relevant for your project. Next. And the last part, probably this is most interesting for most of you, that we actually can provide this mechanism to allow extension of this DCSO with some organization-specific concept, attribute, and relation without having to deal with polluting the core of the DCS. In here, this is the natural extension capabilities of an ontology. So you can make a subclass of a concept to derive all the attributes and relation that it contains. In here, what you need to do, you have to define your own namespace for your organization, for example, and then you can provide this your additional attributes, relation, and concept through subclass relation. Let's go to the next one. So here, for example, let's say Teuvin wanted to say that, well, our DMP following the standard, but we have some additional attributes that we want to add into there. What you will need to do is that you create this you define your namespace, and then you create this DMP class as a subclass of this DMP. And this way you can actually derive all the attributes and relation it has. Plus you can add your custom attribute that you need for your own organization. Not stopping there, you can also add the relation and additional concept that is needed but not part of the core. And in here, this is addressing the goal number 3, where we facilitate this extension mechanism of the common standard with the subsumption and namespace management. So you can really create your own. You can extend the core, the standard, with your own concept without losing the backward compatibility. So when you integrate all this data together, every single instance of this still can be seen an instance of DMP, but this additional attributes and relation will be kept for your organization. Good. Let's go to the next one. This is my last slide. So in here, how can we use this ontology? So, well, the data stewardship wizard already provide capability to export their data in a Dcso. So making sure that you can have this representation there. And currently, we are developing the transformation from this the instance of our of this Dcso ontology to the JSON format and vice versa. So something that you already created before using the JSON format can be used and transformed, and yeah, the other way around. Other things is this instance validation. So if you create an instance of this ontology, you want to make sure that it's conform the certain constraints. So make sure that it's valid. Now we are developing this. We already have something for checks, and now we are also doing something for Shekel. That's all from my side. So if you are interested in this work and want to collaborate with us, please contact me or Joao, and we'll be happy to assist you with yeah, to go through with your use case. Thank you.
Thank you very much, Faja, and sorry for the problems with your screen sharing.
No worries.
Are there any questions for Fajar? If not, maybe let's then continue to part 3, and I'm handing over to Paul, who will take care of the maintenance of the recommendation. Thank you very much to all the speakers once again. You are muted, Paul. We cannot hear you. We can see your screen.
Okay, I think it's on now.
Hear you. It works, yes.
Okay, sorry about that. Okay. Good. Well, thank you, Thomas. So I'm going to talk a bit about the maintenance now. So as Thomas said earlier, the working group is now in RDA's maintenance mode. So we are effectively now stewards of this recommendation. Sorry, it's slightly confusing not being able to see the slides in the window. So right from the beginning of this, we decided that we wanted to develop and maintain this recommendation in as open a way as possible. In fact, we used the phrase radically open. And we've used GitHub as the main repository for the recommendation, and also used things like the release mechanism there, so that everything is in one place. So you'll be able to see that we're currently at version 1.1. We've had 2 releases since we began this work. So with this process, it's a completely open and public repository, so anyone can create an issue, and people do. And so this way we get people notifying us about bugs, which are usually, because this is essentially a documentation exercise, it's usually that there's some kind of typing error or some such in the documentation. Sometimes we get issues about a lack of clarity in the documentation, things which are ambiguous need to be made more specific or more precise. People are raising suggestions for changes there. More commonly, we're also getting suggestions of extensions, things people would like to see in the standard, and so on. So, as a community, we discuss each of these issues openly using the GitHub issues functionality. By the way, I put the link to the GitHub repository into the collaborative notes document that we're using for this session, so you should be able to find it there. And then sometimes the issues are complex enough or involved enough that they're worth a real discussion. So we have had a number of video calls to go into some of these issues in more detail too. And then the role of the three chairs of the working groups, that's Thomas, Peter, and myself, is to review these labels. We triage them and label them, and we gradually identify where we think there may be a requirement for a change to the standard for a new release, and then we can advise the community about that, and the community will be able to discuss that, as I say, either in the GitHub issue or in dedicated meetings, or even in plenary sessions like this one. We use what's known as semantic versioning. So there are three types of changes which are where the versioning numbers are slightly different. So the first type is a patch version, where we're just really correcting a mistake where it has no material change on the standard, and that's where a version such as 1.1 would change to 1.1.1. Then we have a minor version, which is where we're actually making a change which does change the standard slightly, usually by adding something to it or by relaxing a constraint, but which is not going to break anything which is used in the previous version. It's not so that it is backwards compatible. And then finally, we have the major version, where we would make a change which is significant and is not backwards compatible. So that's a completely new version of the standard. We haven't done that yet, but in such a case, 1.1 as it is now would change to 2.0. That would be a major version change. So currently there are, I think, 12 open issues. Yeah. And you can see those on the GitHub repository, and there are discussions going on under each of those, and some of those are potential changes to and potentially could be a new release. So we thought we might not have enough time to talk in detail about these today, and in fact we are running out of time here. So I'm going to go through some of them very quickly, but please do, if you have an interest in this or a question, or you wish to join the discussion, please do join the discussion on the GitHub issues. That's the best place where you'll see the previous comments and the thread of discussion there. And we will organise extra calls if we need to go into things in detail. We've had 3, as you can see there, and each of those 3 listed there has a link to the documentation that came out of that call, the minutes and notes. So the top three open issues, or the 3 sort of most involved ones, are: number 1, how to indicate that extensions are used, and we have quite an interesting discussion going on there. There are several suggested approaches, and I'll talk about those in a second. Number 2 is the issue of identifiers, where things have identifiers often which are temporary identifiers or internal only identifiers, and then, for example, a data set, and then it reaches some level of maturity that it's given a new, perhaps more globally, a global identifier and a persistent identifier. So we end up in a situation with things having more than one. One of the classic examples of this is a lot of repository systems which use handles for identifiers, but not for citations. And then when the data set becomes something which might be cited, a DOI is created. So there's a discussion about how to recognize this fact and I'll talk about that in a moment. And then the final issue is a slightly more tricky issue, which is around dates and how to indicate the status of things. We have been trying to avoid using descriptive metadata, such as something is planned, or it has already been done, or it's some sort of historical status, and rather than that, to use dates, which requires systems to do a certain amount of date arithmetic. But there is an interesting discussion going on that issue, and I recommend you have a look at that. So the first issue there was about extensions, and we heard a little bit about some of that earlier. So one proposal is to create a way to handle extensions with namespaces and URIs, as shown in this example. The more recent suggestion, which I think actually I started, was to consider moving to using JSON LD instead of JSON, which would allow us to add new namespaces to the context of the JSON LD. It's quite a technical issue. Again, I recommend that you go to that issue and have a look at the discussion going on there.
Hi again. Hi.
The issue about changes in identifiers over time and their cardinality, well, I gave the example of the DOI and the handle, but we also have, in early stages, things will be given internal IDs, which are necessary for the internal data planning, but are not something which people can use outside of that context. Most of the recommendation we created, where it refers to data sets and so on, we borrowed heavily from or reused the W3C DCAT standard. But DCAT assumes one identifier for a data set and then uses the idea of distributions of that data set to recognize that there may be, where you have a logical data set, there may be more than one actual expression of that, different data formats, that kind of thing. And so our solution, we think, is to actually create new distributions for the data sets where there's a change in identifier. Sorry, I'm just seeing the chat, and there seems to be some issues with sound, so I hope you can hear me clearly. And then finally, the issue about making things explicit, is this issue with dates. So what we have been doing is relying on the modification timestamp for the data management plan itself, and where dates around, for example, data sets which have an issue date are compared to the modification data timestamp. This gives you an indication of whether that's a date in the future or in the past. But it was Rob who pointed out that this is somewhat unreliable because the data management plan can have any kind of trivial updates from any of the tools in the tool chain which are using that data management plan, and that modification date can be casually changed. And so this really creates ambiguity, and that we need to be a bit more explicit about how we handle these kinds of dates so that the status of something is clear. And we welcome opinions and ideas on this. Again, you'll be able to go to the GitHub issue and see the issue there. Please do go ahead and comment. And this is where I hand over to Thomas to talk about the funder extension. We're going to continue to use my screen share, so he'll be just getting me to move the slides up. You there, Thomas?
Okay, so it's me again. brief here. So I would like to report on the activity we have been doing since the last hackathon, something we started then, and then we had these calls this year to finalize. What we wanted to do, if you can still see me and hear me, what we wanted to do is we wanted to analyze the existing funder templates, like you can see here in the slide, so from the European Commission, but also from the templates in the US, and we wanted to find how can we map the fields to make it possible to express information from these templates using the standard. And what is new compared to the hackathon that we looked at the templates from the US, the new template from NIH, and we also have revisited the Science Europe in view of the evaluation rubric requirements. Based on that, we have came up with two documents that you can review later. One is the proposal for changes in the recommendation itself, and the other one is the proposal for the possible funder extension. Maybe we could use one of these mechanisms described by Fajar to use for this extension. But let me show you quickly what are the outcomes of this analysis. Next slide, please. Paul, next slide, please. Yes, so this is a proposal for changes in the documentation of the standard. So in this table, you can see three columns. The first column describes the field of the standard. So for example, contributor metadata or data quality assurance. The second column shows you the current description, how the standard currently explains this field. And the last column, proposed description, is how we would like to change the description so that it better fits the requirements of the funder templates. And in most cases, we are not breaking the standard. So basically, in all cases, we are not breaking the standards. We are just doing slight refinements. For example, for the contributor, we also make it explicit that contributors can also be organizations, not only physical persons. For metadata, we add this possibility that if there is no metadata standard in place, you can also link in here the documentation that the funders are asking for. Similar we do for the security and privacy. We make it explicit that if there are any cases when people need to describe that there is a sensitive data used in the research project, and if there are any constraints stemming from that fact, all these concepts on all these constraints should be described in security and privacy. So these are the changes on the description level. Please, next slide. Then there are some small changes in the structure of the standard, and for example, the data quality assurance, which so far was just one field with a text description, we would like to make it a nested field. And in this case, this is an extension that allows us to put more machine actionable information. So not only the text description, but also, for example, an identifier to a quality assurance standard. So this is a minor extension here, but yeah, has an impact on the structure. And the next slide, please. Yeah. And these are all the changes we had identified as possibly necessary for the recommendation itself. Now the funder extension. And these are the fields that we found commonly used, commonly asked by different funders. And we wanted to have just one set of fields for all the possible funder requirements. And the first thing we identified as commonly asked are the related policies. So this would be a field where we could link to all existing documents that the DMP has to comply with. So any legal, ethical, contractual guidelines, procedures, or standards. For this related policy field, we would need have a description and the identifier field. This is a similar structure as we do it so far in the recommendation. Next slide, please. And then there are three properties for the data set that we identified. These are easy reused, target audience, and methodology. So easy reused would be the explicit way to indicate whether the following data set is reused from some other project, basically if it was given and can be considered as an input to the ongoing research. or not, or is it produced or collected or will be generated within the specific project. Target audience is one of these examples when we have to provide non-machine actionable information, this narrative. For example, explaining to whom this dataset can be relevant. So far, we were using description of the dataset for that purpose, but it might make sense to make it explicit. And similar for methodology, we would like to add a place for a narrative where you can describe the methodology, how a dataset was produced, because this was a non-machine actionable information and we didn't have it in the first place. So that's why this may be part of the funder extension. Of course, the question, somebody may ask the question, should it be in the funder extension or should be part of the main standard, of the main specification? This is something I think we should discuss as the community. The next slide. I guess that's it from the, the last slide is, we have some other changes in other parts of the recommendation. So again, it's about this non-machine actionable fields like a restriction explanation. There is a mechanism in the recommendation to indicate whether the data set is open or closed or shared. But if you specify that the data set is closed, that people will not get access to it, funders usually want to know the reason why you are restricting access to it. And again, we've been using so far the distribution description to catch such information, but maybe it makes sense to make this explicit and introduce a dedicated field. Like, for example, we are doing it for the preservation statement, where we are describing all the issues related to digital preservation. That's it from my side, from the work we did on the funder extension. The links are in the presentation, and I think this is something we can and should discuss over the next meetings.
Thank you, Thomas. I'm hoping this is better from me now. I'm sorry about earlier. Okay, so we've got just a few minutes left, so we're just going to wrap up here. So next steps. The working group is as I said earlier, is in maintenance mode. We're still committed to this, so we continue to maintain the recommendation. So that maintenance mode really means making updates, discussing and evaluating and gradually agreeing with the community what updates to the specification are needed, and then making those updates and generating new releases as required. To, as far as we can, supporting adoption, and as we've heard, there's a certain amount of adoption is actively happening now, and we've been involved in quite a lot of that. And then the kind of outreach activities of promoting the success stories and helping the community to reflect on the lessons that have been learned during those adoptions. There's also the active DMPs interest group, which has a sort of an umbrella relationship to this working group, I guess, which is a place for discussion on a wider context of discussion about DMPs. And we've put a question here: what are the new topics we should tackle together to ease adoption of machine actionable DMPs? The interest group is actually running its session today. I think it's in about 30 minutes time, so it's quite soon. So please do join that session as well, where there will be a wider discussion. Yeah, we're really looking for your ideas, comments, anything you would like to share. Kevin, did you want to jump in there?
Oh, I was just going to say it's actually, the session proper starts in an hour. We've I think got a lunch break.
Okay.
Yeah. And indeed, so it's a joint session really between the interest group, all the working groups that we spun out, as you say, wrapping up well, as you've been doing here. Where have we got so far? Where should we be going next?
Thank you. So now is time for that session. So that will be, well, I won't say what time it is because it's different for all of you. An hour from now. So yes, finally, the recommendation, which is the heart of, it's the output of this working group, essentially. I mean, clearly there's a lot more surrounding outputs, but the main one is the recommendation, and that lives on GitHub, as I said earlier. There is a DOI there. So please do participate or contact any of the three group chairs. That's us there. We're interested in questions, ideas, and particularly we're interested in knowing about adoption and success stories from you, the community. Yes, Thomas has put the recommendation DOI there, so that's how to cite this. I think that's actually indicated on the RDA page as well. So please do cite this. It helps us to get wider recognition and adoption of the standard. And that's the final slide. It's just a list of some of the publications which we've generated during this work. So I'm going to end there. I guess we have 3 minutes or so for questions. So I haven't been monitoring the Q&A. Are there any questions there that are about this final bit? There's a question from Joy. The example value in the table Thomas showed is a great start, but wondering if we might need something on accepted forms of evidence too, i.e. how can we tell if something has been done or addressed for different aspects? Thomas, do you want to comment on that? Are you there? Is anybody there?
Yeah, I think I crashed, but I'm
Okay.
back. So I don't see the question. What's the question? Can you repeat, please?
So it's a question from Joy. It says, the example value in the table Thomas showed is a great start, but wondering if we might need something on accepted forms of evidence too, i.e. how can we tell if something has been done, addressed for different aspects? If that isn't clear, perhaps Joy could jump in and ask the question.
I think so, because I don't remember which table Joy is referring to.
Okay. Do you want to jump in, Joy, and ask that? Oh, Joy says she doesn't have a microphone, so she'll email it later. Okay, let's not pursue that then. I don't think there are any other questions that weren't about earlier presentations, so I think we can probably declare this session finished. The collaboration notes document has the various links. Thomas will be sharing the links to the slides. Thomas, are you going to put those into? Oh, okay. They're going to go on to the output page for the working group. But I think we'll put the link into the collaborative notes document as well, just so that people can get to those easily. And as I said earlier, please do feel free to go to the GitHub repository issues and read some of those issues and comment if you have any feedback you want to offer there. I think that's it from me, Thomas.
Yes, I think that's it. I just made a mistake. It will be in this file repository of the working group, not in the outputs. Sorry, my mistake, but we will add them very soon, the slides.
Yeah.
So, thank you very much for the participation, and I'll hopefully see you at the next plenary.
Thank you. Thank you, everybody. Bye now.
Thank you.